Okay, dear students, in this problem, when you look at the problem, what all things can be calculated based on our previous learning? Let us try to assume here. Here, R1, it is already given R1, R2, R3 of 5 ohm resistor, R1 of 5 ohm resistance, R2 of 10 ohm resistance and R3 of 30 ohm resistance. They are already given. And what is to be calculated? As we know already, the current through this resistor will be I1. Through R2 it will be I2. Through R3 it will be I3. So we can calculate the current through individual resistors. We can calculate here. Means through R1, R2, R3, how much current is flowing we can calculate. So in this diagram, it is already asked in your textbook. What they've asked? I1 is equal to what? I2 is equal to what? And I3 is equal to what? It is already asked. Next, here total current in the circuit, how much it will be there then? Because based on the sum of these currents, we get the total current or not. So that can also be asked. So I is equal to what? Next, the total resistance in parallel they are there. What will be that effective resistance in the circuit? That can be calculated. So let us write it like this. Rp is equal to what? Then what is given then? Given is only one thing, that is one resistor they have given and the potential difference, both they are given. So in given, R1 is how much it is? 5 ohm. R2 is 10 ohm. R3 is how much it is? 30 ohm. These are given and potential difference is also given. How much it is? 12 volt. 12 volt. Now we have to keep it in the mind that we have already studied in the previous class. What we have studied? In a parallel combination of resistances, the potential difference remains the same across individual resistors or across the combination. It remains same. It does not divide there at all, potential difference, in case of parallel combination of resistances. Whereas the current, it breaks, it divides in the form of I1, I2, I3 related to what? R1, R2, R3. Like this divides. So we need to calculate I1, I2, I3. We can easily calculate now. What we have to start? How we have to start with this problem? We have to start by taking first I1, by calculating I1, because potential difference it is already given, that is 12 volt. We are having resistor R1, means resistance of resistor R1, that is also given. So I1 can be easily calculated. So you start with solving I1, I2, I3 first. So how much do we get here? I1 will be equal to, according to Ohm's law, what is that? Phi by R1, right? Phi is 12 volt. R1 is how much? 5. After dividing 5 ohm, after dividing this, 2.4 current we are calculating, so it is ampere. Next, I2, by calculating I2, phi by R2 we get here. Phi is how much? 12 volt again, and divided by R2 is how much? 10, it is 10 ohm. After dividing this, 1.2 ampere we get, and I3 when you calculate, phi by R3, phi is how much? 12 volt. R3 30, it is 30 ohm. 30 ohm. After dividing this, how much you get? 0.4 ampere you get. Now you see, I1, I2, I3 we got, right? We can calculate easily, we can calculate what? Total current. How do we get total current? We have studied in a parallel combination of resistances, the sum of the currents through each resistor gives what? Total current in the circuit, that we have studied. So according to that, I is equal to I1 plus I2 plus I3. Now by adding this, I1 is how much? 2.4 ampere plus 1.2 ampere plus 0.4 ampere. Now inside, let us add this 2.4 plus 1.2 plus 0.4 ampere. After adding this, how much do we get here? This will be equal to, let me write it here only, 2.4 plus 1.2, 3.6, 3.6 plus 0.4, it is 4 ampere. We are getting 4 ampere current. So I is equal to 4 ampere V dot. Okay, this is total current in the entire circuit here. These are the currents through each resistors. Okay, R1, R2, R3. This is total current in the circuit across the combination, we can say combination of the resistances. Now coming to these resistances in parallel, we are supposed to calculate. These resistances in parallel we can calculate like this: 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3, right? 1 by R1 is how much it is? 5, right? 1 by 5 ohm plus 1 by 10 ohm plus 1 by 30 ohm. Yeah. After this, taking LCM, we get 30 as LCM. 5 6 are 10 3s are. So this becomes 6 plus 3 plus 1. So total how much do we get here? That is 10 by 3, 10 by 30. Here 10 ones are 10 3s are 1 by 3 we get here. 1 by 3 means 1 by Rp is equal to 1 by 3 ohm we got, right? Then this gives what? Rp will be nothing but it is just 3 ohm. This is how we can calculate the total resistance in the circuit. Another method is there for calculating this equivalent resistance. How you know? Here potential difference, total potential difference we will be knowing, and total current also will be knowing. Then easily we can calculate that what total resistance also. How? For example, here Rp is nothing but potential difference divided by current. Potential difference is how much? It is 12 volt divided by current is how much? We have calculated, that is already 4 ampere. 4 ones are 4 3s are, right? So this effective resistance, or equivalent resistance, it will be equal to what? 3 ohm. Like this also we can calculate. This is another alternate method we can see here. So these are the methods. This is how we can solve. In this, what we are doing here, separately we are taking I1, I2, I3, and we are adding all I1, I2, I3 to get the total current. But whereas in the previous circuit what we have learned, there it is different. Okay. There what we are doing, the total effective resistance we are finding, and that total potential difference we know. Through that we are finding the total current in the circuit there. Okay. This is how we can solve the problems based on series combination of resistance and parallel combination of resistance. In the upcoming videos, we will go ahead on solving some other problems based on series combination and parallel combination of resistors. Okay, thank you.